Hey guys, welcome back. Now that we have seen how polynomial regression works and why do we need to do polynomial regression, the thing we need to do now is to implement it in code. Now, as we have seen behind the scenes of the polynomial regression, now we are ready to write the code. And when we will write the code, we will understand every detail, how and why the working, and how, if this code works in this way, how does it work in this way, and why does it work in this way. So let's hop on to the laptop and see how can we implement the polynomial regression. So first of all, we need to import the libraries, and we will be importing NumPy, Pandas, and Matplotlib library. So let's import them. After importing the libraries, what we need to do is first we need to load the data into a data set. So how can we do that? We have to copy the code, we have to copy the path of our data set, and let us store that value of the path in a path variable. I have copied this as before this video. So now as we have the path of the data set, what we need to do is to use the pandas to read that data. So we will be storing that data in data variable, and let's do pd.read_csv for reading the CSV files and give it the path. And let's see how this data that we have looks like. So we can do that data.head, and as you all know, the head method gives the first 5 elements of the data set. So now we can see the data first 5 elements of our data set. We have the position column, we have the level column, we have the salary column. So now as we can see, the position column is a character column, so we are not going to talk about this the characters and categorical things in this chapter. We will be focusing on 2 columns, that is level and salary, because both of these are integers. Now we will be focusing on them. So what do we need is to divide this data set into input features and the output features. As you can see, the input feature is level because we are going to take 2 columns, level, and the output feature will be salary. Now in this example, what we are concerned about is to predict the salary based on the level of the employee, based on the level for which he is applying. Suppose the employee is applying for 5th level, so how much salary should we give to him? Now that we have loaded our data into our data set, into our environment, what we need to do is divide this data into 2 features, that is input feature and the output feature. As in our case, the input feature is the level and the output feature is the salary. So what we will be going to do is say x equal to, we will say data.ilog, and we are using ilog function. So we will say get all the rows and get the first column, that is the from the first column, that is 0th column is the position column and first column is the level column. Get the first column from the first column up to the end, but not including the end. And since we know that we are converting these into NumPy array, so what do we do is we call dot values. And in the same way, what we will do, we will say get us the y. How do we get the y? We say data.ilog, and we will say get all the rows and get us all the last column, only the last column, and say dot values. So if we will run both of these cells and see what is in x, we will see that there is only the level column, and if we will see what is in y, we can see that there is only the salary column. Now that this is out of the way, the dividing of the data set into features of input and output features, let us focus on constructing the polynomial regression model. First of all, let us see why do we need a polynomial regression model. If we can plot the scatter plot of our data, if we can plot, see, we say plot.scatter, and we will give it x and y, and if we will see, there is a relationship we can see that this is this kind of a relationship. So you can see that this relationship is not that great, that this relationship is not linear in any way. It is not linear in any way. So what do we need to do? We need to try to predict the line of best fit in a curved fashion. Now before doing that to predict the line in this fashion, what we need to do, we will see if we will train a simple linear regression model, how does that look? So let us do that. So we will say from Sklearn dot linear model import linear regression, and we will say model 1 is equal to linear regression, and we will try to train this model on our data. So we will say model 1 dot fit, on which data we want to fit it is x and y. So as we will see that the message, it says linear regression and this and this and this, so it means that our model has been trained successfully. Now let us try to visualize the predictions on the graph. How does the line look like that this model will predict on the graph? So we will say plot dot scatter x and y, and we will say plot dot plot x, and we will try to plot the model between x and the predicted values, that is model 1 dot predict x, and we will say get us the red color. So now if we will see, you can see that it predicts this line. So it's not that great. This line is not that great. It does not fit the data well. So for this reason, we need to get the line of best fit for this data in a curved fashion. So how do we do that? First of all, we need to get the polynomial features. What are the polynomial features? We have different kinds of polynomials. We have degree 1 polynomial, that is simple, y is equal to mx plus c. We have degree 2 polynomial, that is y is equal to ax square plus bx plus c, in this way and so on. If we say, suppose, get us the polynomial values for 2-degree polynomial, so what we will get, suppose we have an element data point of 2, so we will get the value for 2, we will get the value for 2 square, we will get the value for the constant. In this way we will get the values, different values. So what we need to do is to generate those polynomial values. So how can we do? We can simply say sklearn dot pre-processing import polynomial features. Now what we need to do, we need to initialize this polynomial feature. Degree of the polynomial we want that to be. So we will say x polynomial is equal to polynomial features, and we will say degree 2, means we will get the degree 2 polynomial features. We have created a model for polynomial features of degree 2. Now we need to fit the model and we need to transform our data using this model. So what we will say x features is equal to x polynomial dot fit transform, and we will say what we need to do is fit the value x into this model and then transform those values into according to the equation, according to the degree we just gave. So now if we will see what are the x features, you can see how it looks like 1 and 1 and 1 and 1, 2 and 4. These are the squares, 3 square, 4 square, 5 square. In this way these polynomial features are generated. Now what we need to do, we need to use these polynomial features to train our model. So what we can do is say model 2 is equal to linear regression, and we will say model 2.fit. We want to train it on the data that we just generated, and we have the x features and we have the y variable. Now if we will see, we just trained the model. Now if we will see how does our line look like if we plot the same thing, and if we plot the line of best fit that we just generated, we can see that this looks far better than the previous one. And in this way we can go on increasing the degree, and we can see that our model looks great. Now let's copy the previous code so that we will see how does this code look for, how does this line look for degree 3 polynomial, and we will say get us the polynomial features for degree 3. The code is same, and we will train the model, the next model, on the new generated features. And if we will plot the same thing, we can see that now it looks far better than even the previous one. And if we will again copy this code, and increase the degree to 4 and do the same, you can see the line tries to fit every data point. Okay, so this is how we implement the polynomial regression model, and this is how we try to get the predictions when we have a relationship that is polynomial in nature, that cannot be satisfied using the simple equation of line. So we need a more complex relationship. This is how the polynomial regression is implemented using Python. So this was it, guys, for the polynomial regression. I hope you like this video. If you like this video, please do share, subscribe, and like the video. Thank you so much.